So Monday, March 30th, 2020. So the craziest thing just happened. I literally got more than halfway done with this actual video, and then my iPad said you've run out of storage. Which, whoops, I forgot my iPad. Well, actually, the school's iPad doesn't have unlimited storage, and so I ended up deleting all the videos that I've already posted on YouTube. So hopefully that problem doesn't happen again. So what I'm going to do for the first 5 problems is pull this paper down slowly for each individual step. So anyway, let's get on with it. 4 times the square root of x plus 1 is equal to 21. See if you can solve this problem independently. So first thing I'm going to do is I'm going to look at the layers. First things first, that's x already isolated, then it gets square rooted, then it gets multiplied by 4, and then it gets added by 1. Oh, geez, I gave away the answer. But anyway, so if I've got a square root, then times 4, then plus 1, I need to undo those layers by subtracting 1, dividing by 4, and squaring in that order. So let's get on with the problem. Okay, so I'm going to zoom in so I don't give away the answer. So I'm going to subtract both sides by 1. So 4 radical x plus 1 equals 21, gets subtracted by 1 on both sides, leaving me with 4 times the square root of x is equal to 20. And now I'm going to divide both sides by 4 because I got to undo the second layer. Now divide both sides by 4, and you get square root of x is equal to 5. And now square both sides because that's that's the innermost layer. So then if I square both sides, the square root gets canceled out. And finally, x is equal to 25. I checked my work on the right side. If I plug in for x, 4 times the square root of x plus 1, I'm going to plug in x equals 25. Using PEMDAS, because technically exponent comes before all this, square root is technically an exponent, we've got 4 times 5 plus 1, the square root of 25 is 5. 4 times 5 is 20. 20 plus 1 is 21, and that's what we wanted all along. Okay, moving on to problem number 2. I'm going to zoom in close so I don't give away the answer. See if you can do problem number 2 independently by using the pause button. Square root of x plus 7 is equal to 3. Okay, so I'm going to go to the right so I don't give away any answers. I'm going to establish the layers of x. First things first, that x is being added by 7 in the first layer, and then it's going to be square rooted. So added by 7 and then square rooted. So I need to square both sides and then subtract 7 from both sides. So let's stick to the plan by squaring both sides of the equation. Then the square root and the square cancel each other out, and I get x plus 7 is equal to 3 squared, or 9. Then I need to subtract 7 from both sides to get to the innermost layer, and I get x equals 2. Therefore, I'm going to plug in my work, and I'm going to get the square root of x plus 7, where x is equal to 2. Well, 2 plus 7 is 9. And the square root of 9 is 3. And that's the output I wanted all along. Okay. See if you can do problem number 3 independently. Notice it's the cube root of x minus 9 is equal to negative 1. Use the pause button to do this problem independently at home. So let's take a look at the layers. First things first, that x is being cube rooted, and then it's being subtracted by 9. So if at first, I'm going to put my hand right here so it doesn't give away anything. If the first layer is to be cube rooted and then subtracted by 9, in what order do I need to undo the layers? Well, I need to undo the minus 9 with plus 9, but how do I undo a cube root? So a square root can be undone by squaring both sides. Therefore, a cube root can be undone by cubing both sides. Let's stick to the plan. So first things first, I'm going to add 9 to both sides of the equation. Negative 9 plus 9 cancels out and gets me 0. And negative 1 plus 9 should get me positive 8. So I've got the cube root of x is equal to 8. I'm going to undo the cube root by cubing both sides. So the cube root of x cubed and 8 cubed. The cube root will be canceled out. And therefore, x is equal to whatever 8 cubed is. I looked it up in the calculator, 512. And to me, whenever I see big numbers, I usually get paranoid, like, wait a minute, did I do this right? You guys know what I'm talking about, where you're in class and you have a problem where the answer is like, that can't be right. Fear not, always check your work. So if I plug in x equals 512, so the cube root of x minus 9, where x is 512. Well, the cube root, you look it up in the calculator by doing, let me get my calculator just to model it. So 512, I want to take its cube root. Hey, go back to the previous test. How do I take the cube root on a calculator? Yeah, take it to the 1/3 power, and that should get you 8. So 8 minus 9 is equal to negative 1. That's what we wanted all along. Okay. Problem number 4. All right. Look at this white piece of paper while I get the great answers already there. Sorry about that. All right. Hopefully that doesn't happen again. All right, see if you can do this problem on your own. Problem number 4. The cube root of 2x plus 7 is equal to 3, where the 2x plus 7 is in the radical. And again, it's a cube root. See if you can do this problem independently. Okay, so use the pause button if you need more time, if you want to do this independently. So let's look at the layers of x. First things first, that x is getting multiplied by 2. Then 2x is being added by 7. And 2x plus 7 is getting cube root. So the layers go times 2. Sorry about that. Let me hide my hand. Cube root is going to get times 2 plus 7 cube rooted, and those are all the layers. So I need to undo those layers by cubing both sides, subtracting 7 from both sides, and then dividing by 2. So first things first, I'm going to cube both sides. So if I cube both sides, I get the cube root of 2x plus 7 getting cubed is equal to 3 cubed. That cancels out the radical, so I get 2x plus 7 is equal to 27. And come on, that's just algebra right there. I mean, this whole class is algebra 2, but that's algebra 1 at this point. So 2x plus 7 is equal to 27. I'm going to subtract 7 from both sides. 2x is equal to 20. And I'm going to divide both sides by 2 and get x equals 10. I'm going to check my work on the right. First things first, I'm going to plug in x equals 10. So 2 times 10 is going to get multiplied. So that's 20 plus 7 in the cube root. And that's the cube root of 27, which is what we wanted, 3. Okay. See if you can do problem number 5 independently. 2 times the cube root of x minus 3 is equal to 4. Pause the video if you want to try this problem independently. Well, I'm going to look at the layers. First things first, let me get my pen. So first things first, that x is getting subtracted by 3, cube rooted, and then multiplied by 2. I'm going to undo those 3 layers. So I'm going to undo the minus 3 layer, the cube root layer, and the times 2 layer by going from outermost layer to innermost layer. First things first, I'm going to divide by 2. Then I'm going to cube both sides. and then I'm going to add 3 on both sides. So I divided both sides of the equation by 2. And that gets me canceling out the coefficient of 2 and 4 divided by 2. So the cube root of x minus 3 is equal to 2. Now I'm going to undo that layer by cubing both sides. The cube and the cube root get canceled out in the process, leaving me with just x minus 3 is equal to 8. Now, add 3 on both sides, and x should be equal to 11. It's one louder, you see. X is equal to 11. So check my work. I'm going to plug in x equals 11. 11 minus 3 in the cube root is 8. The cube root of 8 is 2, so this is 2 times 2, or 4, and is that the output we wanted all along? Oh yeah, you bet it is. So at this point in the video, it timed out. It said, you've run out of storage. So I got like only part 1 of this done. So once again, see if you can do this problem independently. So I looked at the layers of x, and yeah, you can see where I left off. First things first, x is being multiplied by 24, then it's going to get square rooted, then it's actually going to get multiplied by -2, and I left off saying, hey, if it makes you feel more comfortable to put parentheses here so it reminds you of multiplication, then do so. But remember that a number in front of a function is called a coefficient. So that -2 in front doesn't mean it's getting x is being subtracted. It means it's getting multiplied by a coefficient of -2. And then after that, that whole thing is getting added by 13. So I'm going to undo the layers in a very particular order. I'm going to undo plus 13 with minus 13. I'm going to undo divided by, I'm going to undo times -2 by dividing both sides by -2. And then I'm going to undo the square root by squaring both sides. And then I'm going to undo the times 24 by dividing both sides by 24. So we have a plan. Let's stick to the plan. So first things first, let's subtract 13 from both sides. Now this feels more natural, rather than me just holding a camera. it's like having a slideshow of my trip to my family vacation or something like that. Like, here's me in front of the Statue of Liberty. So I've got -2 times the square root of 24x is equal to, well, negative minus negatives getting combined becomes more negative, so that becomes -24. And now I'm going to divide both sides of the equation by, sorry about that, I'm just writing. Dividing both sides by -2, so that cancels out. And that gets me the square root of 24x, the whole thing's in the square root. Negative divided by negative is positive, 24 divided by 2 is 12. So the square root of 24x gets equal to 12, and I've cleared these layers. And now I need to square both sides, so I'm going to get my green. I'm going to square both sides of the equation so that the square and the square root can cancel each other out. So now I've got 24x is equal to 12 squared, which is 144. Now I've got 24x equals 144. My final undo layer will be to divide both sides by 24. So if I divide both sides by 24, I'm just going to have a theory. I think it's 6, because if 12 dozen makes 144, and if I just multiply one of them by 2, that's just a little, and then the other one has to be cut in half. So 144 divided by 24 is 6. It's just a little number theory thrown your direction. So x is equal to 6. But wait, I don't believe you. I'm going to check my work by plugging in x equals 6. So negative 2 times the quantity of the square root of 24 times x, in this case 6, plus 13. And I'm going to trust my judgment on this, that 24 times 6 is 144. Yep. So 24 times 6 is 144. So negative 2 times the square root of 144 plus 13. Well, that's negative 2 times 12 plus 13. Negative 2 times 12 is negative 24 plus 13. And that's going to be negative 11. Is that what I wanted? Yes. Check. Okay, see if we can do number 7 independently. Okay. The cube root of 12x minus 13 equals negative 7. So I'm going to circle the x. I'm going to rewrite the problem. And again, you don't have to do it in this particular way. This is the easiest way for me to teach. So I'm going to look at my x. It's going to get multiplied by 12. And then after that, 12x gets cube rooted. 12x gets cube rooted. That gets subtracted by 13. So now, how do I undo these 3 layers from outermost to innermost? So now, minus 13 has to be undone by adding 13 on both sides. Cube root must be undone by cubing both sides. And then times 12 must get undone by dividing both sides by 12. We have a plan. Let's stick to the plan. First things first, I'm going to add 13 to both sides. And now, that cancels out, leaving me with the cube root of 12x is equal to 6. Now I'm going to cube both sides. Get my green. So if I cube both sides, that kills the cube root. And now 12x is equal to, I'm pretty good at this part, 6 cubed. 6 to the third power is 216. Now I need to do the final undo step by dividing both sides by 12. Now, whatever 216 divided by 12 is, let's get this party started. 216 divided by 12 is 18. So x is equal to positive 18. Check your work. So 12 times 18 goes in the radical. 12 times 18. I'm going to check with the calculator just to make sure. You never know. 216. The cube root of 216 minus 13. Check my work by applying 216 to the 1/3 power, which is 6. 6 minus 13 is negative 7. Is that what I wanted all along? You bet. All right. 3 more problems and then we'll call it a day. See if you can do this problem independently. 10 times the square root of 8x plus 3 is equal to 30. Oh, by the way, this answer has a fraction. Do not be alarmed. Okay, so I'm going to put a bullseye on that x. So now I've got 10 square root of 8x plus 3 is equal to 30. What are the layers of x that I need to do for this problem? Well, first things first, times 8. Then 8x gets added by 3. Then 8x plus 3 gets square rooted. Then 8x plus 3 square rooted gets multiplied by 10. Now, let's undo those layers. All right, undo step, outermost layer, undo that times 10 by dividing both sides by 10. Undo that square root by squaring. Undo that plus 3 with minus 3. And undo that times 8 by dividing by 8. We have a plan. Let's stick to the plan. First things first, I'm going to divide both sides of the equation by 10. So that 10 knocks out, leaving me with the square root of 8x plus 3 is equal to 30 divided by 10, also 3. Now, I'm going to square both sides. So if I square both sides, the square root and the square knock each other out. And that leaves me with 8x plus 3 is equal to 3 squared, which is 9. And now I'm going to subtract both sides by 3. So if I subtract both sides of the equation by 3, that gets me 8x is equal to 6. And now I'm going to divide both sides by 8, which is, you can write this as x equals 3/4, or I like a decimal in this case because it ends, and I'm going to plug it in. You can put 3/4 if you like, or 0.75, but please reduce the fraction. So I know that it's 6 over 8, but please, this is algebra 2. Simplify the fraction. So let's plug it back in, because even I get concerned, like, did I do this right? 10 times the square root of 8x plus 3, where x is equal to 3/4. So 0.75. So I've got 10 square root. 8 times 3/4, I believe, is 6, but I'm showing my work. 6. So then I get 10 times the square root of 6 plus 3. 10 times the square root of 6 plus 3, that's 9. 10 times the square root of 9 is 3, and I get 30. Number 9. Okay, the cube root of 4x plus 2 minus 6 is equal to negative 10. I see what they're trying to do with this one. So I'm going to circle that target and apply the layers. All right, let's see if you guys can do this problem independently. All right, first things first, times 4 plus 2, getting cube rooted, and then subtracted by 6. Here we go. I want to undo all those layers. Plus 6. Cube minus 2. Divide by 4. All right. I'm going to add both sides by 6. And that gets me the cube root of 4x plus 2 is equal to negative 4. And now I'm going to do the next one, which is cube both sides in my green. The cube root and the cube knock each other out, getting me 4x plus 2. Well, if I put negative 4, yes, the parentheses are super important. Negative 4 in parentheses to the third power, so that's negative 4 quantity to the third power. That is negative 64, because it's an odd exponent. So that's negative 64. So 4x plus 2 is equal to negative 64. I'm going to subtract both sides, and then I'm going to divide by 4. So that gets me 4x equals negative 66. 4x equals negative 66. I'm going to divide both sides by 4. And I'm pretty sure that 4 goes into 64, but not 66 a whole number of times. So negative 66 divided by 4, I believe, I'm going to take a guess. Is it negative 16 and a half? Yes! Negative 16.5. Negative 16. So negative 16.5. And just for the sake of time, because I know I want to keep this under 30 minutes, so I'm going to plug in 4 times negative 16.5. And then I'm going to add 2. And then I'm going to take that to the cube root. So parentheses negative 64, getting cube rooted. And then I'm going to subtract 6. There we go. So it works even if there's a decimal or a fraction. All right, last one of the day. And I'll see, the reason I'm making it a long one is because we don't have Tuesday or Wednesday, so we have Thursday. Anyway, so let's do this last one just for fun. Negative 4 times the cube root of x plus 10 plus 3 is equal to 15. Okay. All right. First things first. Plus 10. Then it gets cube rooted. Then it gets multiplied by negative 4. Then it gets added by 3. Okay. So let's undo those layers by going backwards. Minus 3. Divide by negative 4. Cube. Minus 10. Let's go. So minus 3 on both sides. That means it's negative 4 cube root of x plus 10 is equal to 12. Then I'm going to divide both sides of the equation by negative 4. That clears off these two layers. Now I've got the cube root of x plus 10. 12 divided by negative 4 is negative 3. And now, how do I get rid of that cube root? I'm going to cube both sides. Remember parentheses. So that cancels out. So I've got x plus 10. Negative 3 quantity cubed is negative 27. So now I'm going to subtract both sides of the equation by 10. And x is equal to the ever exciting x equals negative 37. For the grand finale, here we go. X equals negative 37. And we're going to plug it in. Negative 37 plus 10 is negative 27. And then that gets cube rooted. The cube root of negative 27 is negative 3. Negative 4 times negative 3 is 12. And then finally 12 plus 3 is 15. Is that what we wanted? Yes. All right. So we did a lot today because I will see you guys on Thursday. Have a great Monday.